pages. It wasn't big data. But it's also at the very front of the book. It's a very important story at the same time. And so, to me, like that's a good example of artisanal data. What's artisanal data? You ask to yourself. I mean, at this point you know. But I'm talking about like when you kind of like dig in, get your hands dirty to your big data or machine learning pipelines to get some more curated, slow, maybe local data. And at the end of the day, the thesis is like no one's too fancy to look at their data, right? No matter how many cool technologies you're using and data set centers you're spanning or whatever, algorithms you have, like at the end of the day, you gotta get your hands a little dirty if you wanna make the good insights. My father-in-law tells me this thing when we're grilling sometimes. He says, if you're looking, it ain't cooking, right? Because the heat of the grill is like too low or whatever. So is that true? Maybe. But I mean, if you flip it on like data, you can sort of say, if you're looking, your data is cooked. Yeah, thank you, appreciate it, I get it too. So yeah, I think it works. Okay, so now at this point, it's like, why should you care? You know, is it just a fancy word for something we all do? And look, give me a second, and then yes, this is just a fancy word for something we all do, but that is literally the point of why I'm here at 6:30 p.m. after getting heat stroke. And yeah, look, if you gotta go to the bathroom, just go to the bathroom, guys. So here's 3 ways that we use artisanal data to help us at Factual. These are like 3 case studies from past couple years. So first up, I'm gonna talk a little bit about our places data. So lots of records, lots of countries, lots of categories, tons and tons of data. We source it from an open web crawl. We get a lot of data from partners. We get a lot of data from customers, both like individual users, but also people we license data to contribute data back. And so a lot of that data is just straight up horrible. And so this is a place that used to be in our data set. We said this was a place. It's not a place. This is like a hate page for Tony Romo. But we had multiple unique sources telling us this was a place. And that's bad. And so what we found was that there were tons and tons of places that weren't real. We needed to cut them out. And so we built a system for that. And so actually, one way I like thinking of that is Kierkegaard talks about the noumenal plane and the phenomenal plane, where the noumenal plane is like things that are real in this earth, and the phenomenal plane is like ideas of things. And so we basically uncovered like a third plane, the factional plane of places that only existed in our data set. And they're not just closed, they just like never were or are fake, or the data's so wrong, it's just, what is that? We didn't know. So we built a machine learning model, and here's a graph that doesn't mean anything, and I'm not going to explain, but it should be enough to prove that we had a model. And it worked pretty well, and it was probably like one of the single biggest product improvements that we've had like in my tenure. But we sort of reached this like local maximum, and we struggled with it. And we saw all these places that just didn't have that many signals coming in from the web or from partners or customers and stuff. And it was really hard to distinguish, like, is this real? Is it not real? For reference, this place, I believe, is real. And so we did a lot of traditional stuff. We did some PCA, we did feature engineering, we did like hyperparameter tuning, and nothing was really moving the needle. And in fact, one of the things that really did move the needle was when we sort of took a step back, and by we, I mean Ross, who's sitting right there, the data scientist at Factual, and he actually worked step by step through the data pipeline, right? So we had training data that annotators had taken places from our data and said, yes, exists, no, it doesn't exist. And that's what we train our model on. He like walked himself through that process over the course of a day. Really, like, that's not something that's like particularly fun in the moment, and it takes some time. But from that, he's able to see like, hey, the instructions we're giving to our annotators, like that's not totally accurate. We should update these for certain countries. And not only that, we probably want to only train on things we really agree on, things we're confident in. And so we should actually ask people, like 3 different people to annotate the same place. And it was really successful. So here's another graph where there's a blue line above a red line, so indicating success. So more than the feature engineering or the hyperparameter tuning, it was literally taking a step back, walking all the way through the data pipeline, examining all of those rows, thinking like an annotator and a model and all of those different things that led us to improve our process. A second example of helps us debug things. So at Factual, probably if existence isn't the cornerstone model of the whole company, then place attachment is. So place attachment is the thing that marries location data with the anonymized signals off cell phones and stuff. So it marries places with ad tech. And it's the thing that basically says, given a point on the earth, is this user at a place? And if they are, what place are they at? And the model is, it's kind of new for us. We're working on it a lot. It's exciting stuff. And so we have a lot of features, doing all that cool ML stuff. And so this is a picture of actually one of our software engineers found this, Horace. It's OpenStreetMap's Disneyland, which has like this like insane level of detail of all the dedicated OpenStreetMap people who just went down to the like restroom or annotating the map data. So anyways, at Factual, we procured a ton of like this basically like polygon information about the Earth of just like, here's a building, here's a building, here's a building. And we didn't connect it with, we tried to connect it with places data, because basically for the place attachment model, the best possible feature is like, are you in the same like polygon or building as the Starbucks? Because if you are, you're probably at the Starbucks. So we got really excited about this feature. We did a pretty simple heuristic, because it's kind of hard to figure out which shape represents which business. So we said, give me all the shapes that have exactly one business in them. That's not ambiguous, that's easy. Let's do that, let's run our model. Nothing changed, and that was bad. And so we were all really excited about this. We knew it would be good, but the results weren't there. So we sort of made the data-driven decision to like deprioritize that for a little bit. And it wasn't until kind of recently, and this is all relatively recent, but we basically took that back up and we sort of decided to examine like, hey, are we actually saying that the place matches the shape accurately? And so we sent some data out to get annotated through like an mturk-like service. So that was sort of like getting some measurement, artisanal data stuff. And when it came back, of the places that didn't match, like the vast preponderance just weren't real businesses. And so then one of our data engineers, Eugen, dug into that a little bit, found the artisanal data, and what he saw was that essentially what was happening was the shapes that had one business were businesses that were like weird tax shelters where the address was some residential things. Tax shelters, maybe like at-home designers, places that were just totally irrelevant to the model. And so we are now working on new ways to attach places and stuff, and we're actually making really good results, and it's exciting again. But one of the things that I think helped us here was the ability to sort of go from big data machine learning to small data and actually examine row by row and kind of come up with reasonable hypotheses. So that wasn't, it's good now though. Okay, cool. And so, okay, so you know, it helps us improve things, helps us debug. It's like pretty natural stuff, maybe even obvious. The thing I think I want to really emphasize, and the way that looking at data can be used for the, like looking at small data can be used for the most good, is that it really helps us communicate with each other. So we're a data company at Factual, so we sort of have this reputation of being a bunch of nerds, but even for that, we're all still humans. Okay, and here's another book I can read. This book is about change. It's called Switch. It's really good. And one of the things the authors found was that when we see problems, the way we think we can like find solutions and like change processes, we think that we can analyze a problem, we can think about a solution, and then we can have change. But what they sort of talk about is how that essentially always fails. And that what you need to do is you need to like see a problem and see a solution and then feel it, and then you can have change. And that ultimately, when you're trying to move organizations and people, if you don't have the emotional component, then nothing changes, and you just stand adrift and frustrated. And so one thing we do is we have top-level aggregate metrics for our places data. So we measure, say, like how many places in our data set are unique. We don't have like a bad copy of them in our data set. And we like this metric, and it's pretty good. But one thing that happens is we get into squabbles with like product, or like when we're trying to set goals. You know, like, hey, is like 90-some%, that's pretty good. We can't reasonably improve that. We're done. Don't tell us to improve it. And we sort of like lose color when we're arguing about numbers and trying to be data driven. So one thing that happened was like a couple months ago, this business development guy dropped a ticket for us, and he said, I have a deal with movie theaters. I was looking up the Century City movie theater, where we're conveniently located at 1999 Time with the Stars. And there were 3 movie theaters there. There's not, there's 1 movie theater. You have 2 duplicates. This is really bad. It's making this look bad. And what this example did was it allowed us to sort of, all the teams kind of like came around to this, and we could all agree that that's bad. And we could all hang our hat on that, and we could see it, and we could also feel it that it was bad. And the solution here was like pretty multidisciplinary, right? Like we had to sort of work, like make some tweaks to our categorization algorithms and our existence models and our like clustering algorithms and stuff. And it took like a little bit of effort from a lot of different teams, but absent sort of like a single example for people to like really point to, we wouldn't have been motivated to do it. And of course, when we had this example, we backed it up with numbers, right? We like proved this was actually like a problem worth solving and not just here. So we got a lot better. Here's the Cinerama Dome. That's cool. I think those are actually like different businesses inside of it, and one's the Cinerama Dome itself. It's kind of like, this is like a study I found. I don't know, who wants to even like finish reading that headline? But you know, in the popular press, it's like, yeah, I'm gonna click on that. And I think that's all feelings. So, like, obviously, don't get carried away with small sample sizes. Like, you need to back things up with metrics, right? We're not gonna like change the company direction based on like a single example of a bad movie theater. We need to then like do some like targeted testing around that our aggregate metric missed. Don't under-automate. And in fact, one thing we're doing right now is building a lot of automation systems around getting data in front of people in like an MTurk-like context. And doing that at a much greater scale than we are now. And yeah, high-level metrics can be important too, so don't just like look at good examples and say that that's good. But yeah, I would say in general, no one is too fancy to look at their data, and I hope I've proven that today. If you'd like to contact me, to borrow Yenny's catchphrase, this me, and Factual, we're hiring people on the data team specifically. If you like, even if you're like a full stack developer and you want to learn about big data, yeah, come talk to me. We're looking for a lot of things: big data people, data scientists, software engineers. We got a lot of problems. We have a few problems. We have a lot of projects to going on, and we're building a lot of really cool stuff. So come and talk to me or people in that middle row who are also talented engineers at Factual. So that's it. Thank you.